Hi everyone and welcome to my channel. In this video my topic is transformations and my subtopic is enlargements. This is something that's really done in Form 4, Form 5 and it's covered in math. Now this is my third video on transformations. My other two were on reflections and rotation. So please stay tuned to see what I have in store. Enlargements. Now this topic in math really refers to making something bigger or, believe it or not, smaller. So we need to have two values really, and those values are scale factor as one variable and the center of enlargement. Now the scale factor tells us how big or small the shape is. So the scale factor is a real number. It could be any value. It could be a fraction, it could be negative, positive, and so on. The center of enlargement tells us where, at what point is the shape going to be enlarged or even reduced from, right? So like in this particular case here, we have one B here and a bigger one. So this could be the object and this one here could be the image. Now if that's the case, then perhaps our scale factor was probably 2, right? But however, what if it were the other way around? And that is, say, this was the object now, the bigger one, and then this was the image. Then the scale factor may most likely be probably a half. Or it could even be negative a half as well. Same for the other, it could have been negative 2. But of course, I plan to go through in detail the 4 different categories of the scale factor, right? So now, let me continue. There are 2 methods in which an enlargement can be done. One is using the matrix method and the other one is using graphical method. Now of course, I plan to do both methods, so I would explain both. Now this is my note for the matrix method. The only condition with matrix method is that it can only truly work if the center is 0, 0, right? Or the origin. Once this happens, then we could use this matrix method really easily, right? Now the general form of a matrix is this, K00, K. Now what is K? K is the scale factor or a real number, right? Now say for instance, the scale factor was 2, then it would be 2002. Right? Or if it was a half, 0, 0, a half. Minus as well, I could just stick in the minuses and so on, right? Now once we've established what matrix it is, then we have to multiply this matrix, or well, even if it's this one, by the points that we plan to enlarge or reduce. But these points will be written vertically, as I have here. So your points will be written like this, like say A, B, C, and the points, the coordinates will go vertically, like the XY values here, and so on. Right? Now, of course, I plan to do a fully worked example to show you how. The second method I have here is if we were to use the graphical method. As you can see in my note here, I say to plot, the first step is to plot the points of the object to be enlarged. So let's assume it's A, B, and C, right? Now, I have a little diagram at the bottom here. I want you all to look at this as well. This here is the object and this one here is the image. Now of course I'll get into the note as to how we got from here to here, right? Now so that's the first point. The second point is locate the center of enlargement. Okay, so this now will be the center of enlargement. We're going to draw a line from your first point A to the center of enlargement. So you see this dotted line going like here, that is the line they're talking about in point 3. They're calling that OE. So say here's O and here's A, then this distance is OE. Now there are 4 categories in which the scale factor could fall. The scale factor can be greater than 1, between 0 and 1, between -1 and 0, and less than -1. Now I have notes for each category. So if the scale factor were greater than 1, right, say for example it was 3, right, it means that this object here, this pink object here, is going to be 3 times bigger when we do the image. Right? Or if it was 50, 50 times, etc. Now, what we're supposed to do is we're supposed to measure the distance OE. So say I measure this distance here. Just want to use a little color. And this red line here ends up being, say, 6 centimeters. Right? Now, what I'm going to do is I'm going to multiply that distance by the scale factor. So say my scale factor is 3. I'm going to take that 6 and multiply by 3 and I'm going to get 18. Now, 18 centimeters is a new distance. But that is actually going to be the distance from O here to my new point, which is OA. So it's actually going to extend passing through A and going further out. And this green line here, guys, is going to be 18 centimeters. Hope you all understand that. So meaning the original line was 6 and the extended piece here will be 12. The total line of the green line will be 18 because it's 3 times as big. Now what we have to do after that is repeat this step for all the other points. So meaning you're going to go and measure from here to here B, measure that distance, multiply by 3, and then start back from O and measure out the newly multiplied value by 3. And again we repeat for C and so on. Right? So then we will get these 3 points here and then we could draw it. And we will see that this shape here is 3 times as big as the pink shape. Right? Now that is if the scale factor is greater than 1. Now let me go through some other categories. The second category I have here is if the scale factor was less than 1. Meaning if it's actually between 0, I'll call here S, the scale factor, and 1. So it could be a half, it could be 3/4, and so on. It's a fraction, right? Right. So if it's between 0 and 1, then we do the same thing. We're going to measure the distance from O, say here, to A, which is here. So we're going to measure this distance here now, this green distance here, and we're going to multiply by the scale factor. So say this green distance here was 6 again, and if the scale factor is now a half, then I'll have to take that 6 distance, sounds strange, right? 6 centimeters, and multiply by a half. So I'll now get 3 centimeters. So now I'm going to measure again from O here, but I'm just going to go 3 centimeters. So this other green line here is actually going to A dash here, and at the end of that 3, so that is going to be 3 centimeters, I'm going to put A dash. Now I'm going to repeat this process for B and C. So again, measure out here, get that distance, multiply by a half, and then measure that other thing. So then I'm going to get these 3 points. So we're noticing that these 3 points will now make another triangle which is smaller, and it's actually going to be in between the center of enlargement and the object, because this one here is the object and this one is the image, right? So now let's move on. So when the scale factor is between 0 and -1. When the scale factor is between 0 and -1, it means that we're dealing with values like, say for example, if the scale factor is -1/2 or -3/4 and so on, right? Now the first thing I have here in my note is I say ignore this minus sign. So we're just going to work with the half for now. So we're going to have our center of enlargement here, have our image here, our object here, and we're going to do the same. Measure this distance here, get 6 centimeters. Say it was -1/2, then I will take that same 6 centimeters and multiply by a half. I will end up getting 3 centimeters. Now what am I going to do with that 3 centimeters? I'm not going to measure in the same direction going out like this. No, I'm actually going to measure 3 centimeters going this way. So this distance from the center to wherever 3 centimeters ends, that is going to be A dash. Right? Now when you repeat this process for B and C, you're going to get this distance here, multiply by a half, and you just go out a little bit. Right? So that's the half distance in this direction. Right? And you repeat it here, you will end up getting these 3 points here, which will make the image of this object. Now what we're noticing in comparison to the other one, when the scale factor is between 0 and 1, right, it's still a fraction of the shape. It's a half of the shape, 3/4 size of the shape, and so on, but the image is actually flipped on the other side of the center of enlargement. So that is what you need to know, right? When the scale factor is between 1, the shape is smaller, the image is smaller just like this, but it is actually between the center of enlargement and the object. But when it is between 0 and -1, it's still smaller, just like the one here, but it's actually flipped on this side. The last category I have here for scale factors, if it were less than -1. So for example, if it was -2, -50, and so on. Right? Now what happens here is we do our object here like this. We have our center of enlargement like this. We measure this distance here. So say for example it was -2, right? We will measure this distance here, say get 6. And again we will ignore the minus sign, and we will take that 6, multiply by 2, and get 12 centimeters. And with that 12 now, I will measure outward. meaning from the center here, I'm going to measure 12 here from this distance here. So this red line is actually 12, right? So when I repeat this for all the other points, I'm going to get a shape looking like this. So what ends up happening is that my shape is bigger by however many times my scale factor is. But again, because of the negative sign, it would be flipped, right? Now my last point here is repeat the process for all the other points on your diagram, right? So once you've done this, then we will get a full image. So we'll have our object, our center of enlargement, and our image. Now of course, it's very important that we keep all our construction lines, the dotted lines and so on, so that the examiner would see exactly how you came up with this new shape. Now I'm ready to move on to a question. This is example 1, and it has here a parallelogram, has these vertices A, B, C, and D, and they want us to find the new object, the new image, if we do a center of enlargement, which is the origin, and a scale factor of 2, right? And then in part B, it says the same origin and use a half, and they want us to draw this. Now the first method I'm going to use for this, for parts A and B, would be to use the matrix method, right? So in part A, since it's a scale factor of 2, it will be 2, 0, 0, 2. Once I have that, then I'm going to establish and put my points vertically, A, B, C, D. 2, 1 for A, 3, 3, 6, 3, and 5, 1. Now when I multiply this 2 by 2 matrix by this 2 by 4 matrix, I'm going to end up with another 2 by 4 matrix, which is going to give me A dash, B dash, C dash, D dash, right? So now multiplying here now, I get 2 by 2, that's 4, and that'll be 0, and this will be 2, etc. And I'll just continue with this. So this is what I would get when I multiply the other points. Now moving on to part B. Then, since the scale factor is a half, and also because the origin is the center of enlargement, then I would use a matrix that looks like this. Again, repeating the points A, B, C, and D. I will then get, I'll call this now A dash, A double dash, B double dash, C double dash, and D double dash. Now it's really nice and easy to multiply matrices like this with a lot of zeros in it. Right. So these are my 4 other points. So now that means I've completed this and this. Now we need to draw a graph to illustrate this, right? So let me proceed to that. Now, the first thing I do is I plot my object, which is A, B, C, D, right? And then I will, because I have the matrix method, I already have the coordinates, I just need to plot the points. So that'll be like this. That's A dash. Right, so this blue object, blue dots now, trying to draw some straight lines here. Forgive me please guys, it's kind of hard using this pen. Oopsie. Right, so this guys, this blue parallelogram is actually the enlargement by a scale factor of 2 of the black one, ABCD, right, using the center of enlargement as the center. Now let me show you how we do a scale factor of a half. Now I'm just going to follow these points here. Now the great thing about using matrix method is that 1, it's easy, and 2, you don't have any sorts of measurements and stuff to do, right? So that you could just come on your graph paper and plot. C double dash, right, and D double dash. Now drawing, connecting these red dots now. Right, so this one now is a scale factor of a half, right? So this is how we do this particular question using matrix method, right? So now let me go on, show you the same question, and I'm going to show you it graphically. So if I'm using graphical method now to do the same question, I'm going to do, well, firstly draw up the object, which is ABCD as what I have here. I'm going to locate my center of enlargement, which is here, the center, which is 0, 0 actually, and the scale factor is 2. So I'm going to then draw a straight line going from O to A, and I'm going to measure that, right? So when I measure this line, right, whatever distance this is here, right, I have to measure that and I have to multiply it by 2, right? So say for example, distance was like 4 something, then double of that will be 8. So then I will extend this blue line now so that I would actually get 8 units, right? Now I would stop at the end of 8. So that may be around here, right? So now let me explain. This distance from the center here to here, the center of enlargement to here, was say 4. I'm just assuming, right? Then when I multiply it by 2, because the scale factor is 2, I'm getting 8, right? So multiplying this by 2 now means that I've now started again from the center here, and I'm coming out to 8 centimeters now, which is actually the whole distance of this blue line here. So that is 8 centimeters, the total distance of the blue line, right? So now at the end here, I'm going to put A dash. Now I'm going to repeat this process, meaning I'm going to draw another line from my center to B now, measure, and then extend it further out in double the distance. So that is actually going to go to here. So that is going to be B dash. And of course you repeat again. Sorry, you repeat with C and C that, and D. Now we will get something like this at the end. Get this shape here, which is this light blue shape, A dash, B dash, C dash. Oh, I have a double. Sorry, I meant to put C dash and D dash, right? These blue lines are the lines that you should have if you are doing this enlargement, right? This is what the examiner needs to see. Now let me do part B, which is with a scale factor of 1/2. With a scale factor of 1/2 now, that's for part B, I'm going to measure again O to A, and I'm just going to find 1/2 the distance of O to A, right? So whatever distance it was, say it was 4, I need to erase this 8 here, sorry about that, right? Then I'm going to measure just 2 centimeters out. If this green one was 4, then I'm going to measure 2 instead, so that will end probably here. So here will be A double dash. Now I repeat the process with B and C. Measuring out here. Now it's kind of difficult for me to measure here because I'm doing it online, but I'll just assume it would end up being around here, B double dash. So whatever distance you get, you just find 1/2 of it. Right. So we would end up with something like green parallelogram here, right? So notice it is actually half the distance of the black parallelogram, and it's actually in between the distance of between the center of enlargement here and the actual object, right? So now let me move on to my second example. Now before I get into example 2, I just want to show you all something. Say for example I was given, say, this black parallelogram here and the green one, right? And I wasn't given this one, and I was not given this center of enlargement here. I was given these two, and I was asked to find the center of enlargement, and I was asked to find the scale factor, right? Now what I would do actually is I would actually draw lines that will connect A and A dash, A double dash, B and B double dash, C and C double dash, etc., right? And then what I would do is when I just draw, I won't just draw lines like this, like connecting like that. No, I would actually draw it way out and make them longer, meaning like this. Say something like that. Just fixing it here, right? So I could go like this, right? So that is one line here. Now of course I could go further out this way too, that's okay. Nothing is wrong with that. So I could go further out like that. Right, now I could continue. let me do another line, another 2 points. So connecting A and A double dash, I'll end up getting something like this. Forgive me please guys. Right, say something like that, right? Now what happens here is that I am actually seeing that these two lines cut at around this point. So that is how I know my center of enlargement is 0, 0. So that's one thing done. So meaning, for us to find the center of enlargement, if we were given the object and the image, what we do is we just simply connect corresponding points. A with A dash, B with B dash, or in my case, B dash, double dash, and so on. Extend these lines and see where they meet. And wherever they meet, that is your center. Now, for us to get the scale factor, I need to measure. So I could measure this distance here. I really should not have used green. Let me try another color. I'll measure, say, AD, like here. And then I'll measure this A dash, A double dash, D double dash. And I will divide the two lengths. Now, when I divide the two lengths, I will see that my scale factor is actually a half. Now I will move on to my second and final example where I would use scale factors of negative values. Example 2 now speaks about a triangle PQR with these vertices, right? And they want us to use a scale factor of -2 now with the center of enlargement being the origin. And again, -1/2 with again the center of enlargement being the origin, right? Now, first method I'm going to use again is matrix method. So if it's -2, it's simply going to be -2, 0, 0, -2. And then I'll put P, Q, R. So we write the matrix here, and then we write the PQR vertically. So we get this. And then again we multiply to get P dash, Q dash, and R dash, right? So this would give us right. So those are now my image points, right? So now repeating this process now with a half, -1/2. I just do that. Right? Now we are going to get P double dash, Q double dash, and R double dash. It's going to be -1.5, -2, -2.5, and -1.5. But sorry, and the last one -2, -0.5. Now go into graph paper to get this. So we have our points using matrix method, then we go to the graph paper. So this is my object. And now I'm going to just put in my image points, right, which will be for P dash, Q dash, and R dash. Then these points I'm going to get this blue triangle, which really does look like double the size of the black one. And again, it's flipped, right, because it's a -2 scale factor, right? Now, going ahead now and doing part B, plotting the points, I would get this mini green triangle here, right? Now that makes sense because it will be a fraction of the size of the black one, and it would also be flipped because again it's a minor scale factor, right? Now let me do the same question now, but we're going to use graphical method. Graphical method says that the first thing we do is we plot the object, which is PQR, like this black triangle here, and then I'm going to identify the center, which is here, and I'm going to draw a line from here to the center, right, say from P, and I'm just going to extend it out like this, right? Now of course just fixing this up nice, I guess say something like that. Drawing that line out goes like that. Then I'm going to measure this distance here, right, the distance from O to P, right? Now whatever distance that is, I'm going to multiply by 2. So say that distance was 4 centimeters, multiplying it by 2, I'll get 8. So I'll measure 8 from here. So from here I'm going to measure out to 8 centimeters, wherever that takes me to the end. Now the end at 8 centimeters will be which is actually -6 -8, right? So that is actually the point P dash. Now I'm repeating this process for the other points and measuring the initial distance, which is like say from O to Q. Again measuring this distance here, say I got 6, multiplying it by 2, I'll get 12. So this distance here now will be 12, Then here will be Q double dash, and similarly here too, here R double dash. Now connecting these three, I will get a triangle looking something like this. Now notice this red triangle is the flip of the black triangle because it's a negative scale factor. It's also double the size. Now repeating this process now for a scale factor of minus a half, it will be along these same lines actually. So if it's 4 here, I'll actually go 2. So I will end up here at about 1.5 here. So this will actually be P double dash. Then I'll end up here at about 0.5 thing. That's R double dash, because if I'm measuring, and then Q double dash would end up being around say 2.5 here. Right, now connecting these, I get this. So really, the gist of this whole lesson is to know the difference with the scale factor. The scale factor, as I told you before, has 4 categories. One is greater than 1, then it's between 0, let me call it scale factor K, if K is greater than 1, then it's between -1 and 0, and lastly if it's less than -1, right? So this whole video with these 2 examples, I went through each of these in detail. So I really hope that you all understand, and of course please let me know if you do, and feel free to like, share and subscribe. Thanks guys.